In the last lecture, we introduced pointers in Go, and we said that structs are passed by value and not by reference. And that's why we need to use pointers to make sure that the update or the change is done on the original struct and not the copy. In this lecture, we will present another important concept, which is interface. So today we are going to explore what interfaces are and why they matter and how they allow your code to become flexible, extensible, and powerful. So the question is, what is an interface? In Go, an interface is a type that specifies a set of method signature. If a type implements all the methods of that interface, it's said to satisfy that interface implicitly. So without taking so much time, we jump. I created another folder called interface, and let's try to create an interface. And by the way, I want to create an interface of type called shape. And this interface has the method getArea, or the function getArea, which return a float. So, like we mentioned, interface are method are a set of method, define a set of method signature that are implemented by other type later. So here, the shape interface, it says that any type that has a getArea method return a float is a shape. So let's try to define two types. The first type is a square, which have a side length of type float and a triangle which have the base and the height both of them of type float. Okay, so in order that this type square and triangle satisfy the shape interface, they need to define the getArea method. So as a function receiver, obviously. So let's try to define the function getArea for both type. Let's define it first for the triangle. And this function should return a float. It will return multiplied by the height and multiplied by the base. The same for the square. This time it will return the side length multiplied by the side length. So now, implicitly, the triangle and the square implement the shape interface. So the triangle is a shape, and also the square is a shape. This is because they are now implementing the getArea method. So why this is very awesome in Go? Because now we can write generic function that work with any shape without caring whether it's a triangle or a square or something new in the future. So let's define a function called print area. This function, it will take a shape as a parameter. It can be a triangle, it can be a square, and using the fmt package, we will try to print the result of the getArea function. This function accepts any shape, any type that satisfies the shape interface, and print its area. This is actually what we called polymorphism. It's polymorphism calling the same method, which is in our case the getArea, on different type, and this produce a different behavior. Let's test this within the main function. And let's try first to create a square. The side length, I will give it 4. And we can define a triangle. At the base it will be 3. And the height, for example, it can be 5. And let's call the print area based on this variable that we just created. Let's save the file and try to execute the code. And here we go. We got the area for the square is 16, and for the triangle it is 7.5. So at the face, they define a set of behavior method, but not the implementation. Type implicitly satisfied interface in Go. You can write flexible, generic code that work with any type that implement an interface. This actually guarantee a clean design, decoupling, and also scalability. That's it for this lecture. Let's take a quick break and let's come back in the next one.